The art challenges the technology and the technology inspires the art. Hello everyone. IEEE PSIT Student Branch has organized a special webinar on importance and impact of IEEE standards for emerging technologies. Motivation behind this event was to educate the audience regarding the importance of technical standards and the active role of IEEE in building those standards for emerging technologies. Now, I would like to welcome our guest speaker, Mr. Srikanth Chandrasekaran, sir. He has been associated with the IEEE Standards Association for the past 10 years, focused on developing key programs. Prior to joining IEEE, he was associated with Freescale Semiconductor for 17 years, managing a global electronic design automation R&D team. He received the Elisrel Technical Excellence Award in 2009 for his leadership and contributions to design automation standardization. We welcome you, sir. You can begin the event.
Thank you, Anshika, and thank you, Dr. Aparna. I apologize to everybody for starting this meeting 15 minutes late. So I have a time constraint, so we have to wrap it up by 9:45. Hopefully, we can make it meaningful. Typically, I try to do it in person because it's very difficult to do this virtually. It's difficult to pay attention when you do virtually, and I prefer to do it interactive. But given the constraints, we will do it virtually. Thank you very much for the opportunity for allowing me to talk to you about standards, particularly the standards that are developed in IEEE, and I have a specific focus on the Internet of Things as a pivot point for my discussion today. Ideally, I would prefer that this be a little bit more conversational. The details are not important, but understanding the aspect of standardization is more critical, but we will see how it goes. So let me see if I can share my video. I'll do that. Just give me a second, okay? All right. Excellent. Let's move back to full screen mode. Okay, thank you all. Thanks for the introduction. One particular important point I had to make. I'm a senior member of the IEEE, but what I'm going to talk about today are my personal views. These are views that I'm going to express from my personal experience, and they are not the opinions of the IEEE or the IEEE Standards Association. This is in line with our bylaws that we have within IEEE SA. I assume that everybody uses Wi-Fi today, and I thought this will be a good basis for discussing the topic of standardization. This is a pretty common technology, right? Like I will be very surprised if there is any communities today that or any individuals that do not use Wi-Fi. Can somebody post in the chat window what is the technical term for Wi-Fi, and I will monitor it. I will give it a minute, and then we'll go from there. I'm going to monitor my chat window. If anybody knows what is the IEEE terminology for wireless fidelity, anybody? Or you can unmute yourself and say it also. Nobody knows the technical term for Wi-Fi. Have people heard about IEEE 802.11? Yes, no, maybe. So okay, so virtually it's very difficult to do this. So the technical term for Wi-Fi is IEEE 802.11. So this is a standard that was set by the IEEE way back in 1980s, early 1980s, and the idea was to connect transfer cache between registers. It was on a parking lot. A lot of registers are there. How do they reconcile all the cache? And they decided that they will create this technology for wirelessly reconciling that all the transactions over the day at the end of the day. So this is how Wi-Fi started, and now we are 40 years in. The device that was used to develop Wi-Fi, perhaps is no longer available in the market. In fact, you can see that particular device in the Smithsonian Museum in Washington, D.C. Uh, the reason I bring that up is if you look at the numbers volume game, and I'm going to talk about IoT. Wi-Fi is one of the technologies, and it's not the only technology. It's one of the technologies that connect people, devices, machines to each other. Right. So today we are constantly connected to our laptops or mobile devices or our iPads, and we are interacting either through 802.11 or what has been published as the LTE or the 4G standards, and India just launched the 5G also. And the hunger for utilizing more data, more connectivity keeps on increasing. Today, if I go on the metro or if I go on the train or a plane, everybody is watching something live on a YouTube or on a Facebook, Insta, whatever your like is, on social media. And not only the number of people using it has gone up, but the audio and the video quality has also gone up. It's 4K HD and things like that. Uh, if you look at the market numbers of devices that are being shipped, there are today we have 8 billion devices in use. That's more than the number of people we have on the planet. And every year they are adding 3 million people. That's quite amazing. And Wi-Fi is just not used on the phones or the laptops, but you see a lot of white goods. People talk about refrigerators and things like that that use connectivity constantly. And if you look at the broader aspect of connectivity, if you look at personal area networks, 4G, 5G, then how connected we are increases significantly. So before I get into some of the IoT aspects of it, I'm going to talk a little bit about why we need global standards and the impact of global standards. I am assuming the audience here are perhaps not aware of standardization and have not been involved. I know that some students within India, they have been involved in standards in a couple of different ways. They have done their final year projects, which enabled them to get in touch with one of the IEEE standards because they were developing a standard, developing a particular project that required them to understand and learn standards. And we have had interns at the IEEE office who have worked on certain applications based on specific IEEE standards. In fact, Shreya Nagarpa was from PES. She interned with us a year or so ago. So, and she also published a paper on the work that she did on 2030.5, which is also an IoT standard. So if you look at the impact of global standards, the reason why we are doing this is to ensure interoperability. To simplistically say what we mean by interoperability, today when you buy a phone, you should be able to connect to any of the access points. The access points are connected to a router. So if you look at that, you don't have to buy an access point along with the phone, right? So the phone allows you to connect, and you can buy any phone, so any access point can be connected to any phone, right? So, and not only that, it also ensures backward compatibility in this particular case of 802, where you can have a phone that is Wi-Fi 6 enabled, access point that is Wi-Fi 5 enabled, and they can still talk to each other, right? So that is very important when we talk about planning, designing systems. How do you ensure that the systems talk to each other, and not only they talk to each other, but it's future proof. You don't have to move entire systems as as the technologies evolve. It allows for better cost efficiency. We all know that the price of phones always keeps coming down. Price of white goods, technology, televisions, anything you take, right? Anything that is technology driven. And the reason to do that is once you have a standard, the market size increases. It creates new markets. People can now develop products to the standard, and they can innovate on the application. And so there are more suppliers who want to comply to the standard and provide to the overall system. And once you have that competition, the cost comes down down, and it allows for better cost efficiency. But more importantly, apart from cost efficiency, the economics of it, system interoperability, what you need to understand is standards gives confidence to the consumer, and that's critical. You can have something low cost, but if the consumer doesn't have the confidence that it will work reliably, then it's a challenge, right? So a lot of times, whether reliability comes in the form of safety, a lot of power equipment, substations, transformers, these all have significant safety requirements, and these safety requirements are governed by standards, and sometimes they are also driven by regulation. In India, we have the Central Electricity Authority, who says that the product should comply to certain standards, right? So, and this allows for reduction of market risk. When you are doing a large investment today, any implementation you do that uses technology, that is a fairly significant investment in resources, time, equipment, and you want to make sure that you want to reduce the market risk. The way to do that is through standardization. I'm not sure of the profile of the students that have joined today. I'm not sure whether they are from computer science background or electrical engineering or electronics. But I'm assuming, and I'm going to assume, and if my assumption is wrong, I do apologize. If you are not in the, if you are in other departments. But today, if you look at Internet of Things, it touches upon every department that we can think of. People talk about mechatronics, mechanical engineering. If I design IEEE's own societies, the Computer Society, Communication Society, or if I even design universities and the branches of studies in the universities, perhaps we will do these things very differently, right? Today, there is very difficult. I find it difficult to understand the subtle differences between computer and communication, right? They are all merging, and systems are becoming very complex. Systems uses different technologies. Automotive, for example, there is a lot of sensors in automotive, advanced materials, even the seat that you sit on, they are embedded with sensors, right? So then you have V2V, V2X, vehicle to infrastructure communication, vehicle to vehicle communication. The cars you buy in India today, when you go close to other cars or to the curb, then it gives you a warning, right? So there are quite a lot of technology that is coming in, and if you fast forward 10 years from now, then you'll have AR, VR displayed on the dashboard, and then we are talking already. We have electric vehicles, but we are also talking autonomous systems, right? Driverless vehicles, level 4 or level 5. So all these things come under the very, very 50,000 feet umbrella of Internet of Things, because they're all connected devices in a lot of ways. And when you talk about Internet of Things, people refer to it in different ways. They talk about cyber physical systems, machine-to-machine communication, whether it be the industrial internet or industry 4.0, connected world, all this stuff. And then when we have these names, for the keen eye, for people who are diving too deep, they are all slightly different. They all don't mean the same, but for the purpose of our conversation, we can say that these phrases can be used interchangeably. And the reason they can be used interchangeably is because they have a lot of things in common. One thing common is, of course, everybody is digitizing very deeply. The connectivity is going from local connectivity to global connectivity. We are always connected. We are not just connected inside the homes. And even, if you look at your own usage patterns, you have, if you go to probably cities like Pune and all, they have public Wi-Fi systems, right? A lot of cities around the world, the government itself provides some free Wi-Fi, and not be the fastest, but it allows for certain services to be provided. So we are really the connectivity, and then on top of it, you do mobile wireless apart from the fixed wireless, so which is 4G, 5G. So then the connectivity is ranging from the local to the global, and these are all driven by standards that are being developed by IEEE and others like IEEE, who are looking at how do we do protocol standards. And when we do these things, one of the things that you have to ensure is the amount of data that is generated. We do generate a significant amount of data. And what is the purpose of generating the data? The purpose of generating the data is to ensure that we are able to store it and we are able to make analysis, and then you get machine learning into the picture, and that's where we are exploiting the computing, whether it is machine learning algorithms, deep learning algorithms, AI techniques. And the whole idea behind all this is you have to close the control loop by design. So when we talk about control loop by design, what we want to do is we want to create a global self-configurating systems that are automated and that have the smarts built in. So you have the actuators, they sense, they collect data, then you apply the models and algorithms. And these are all great only if you make specific decisions. And when we make these decisions, you also need to make corrections, and that's where the feedback comes in, and you close the control loop. And as engineers, I'm assuming control systems is a first year or second year course for all engineering students. Control systems are very important, and we prefer closed feedback loops, right? So I talked about the number of devices that are connected, when we talk about the impact of IoT, but also important to understand, it is just not about the impact of IoT, but how have we advanced ourselves through these connected devices? Um, we Today, if you look at any application, there is no application that exists today that is not connected, whether it's a consumer application like a wearable, white goods inside your house, the wellness, health, everything is connected, whether you are monitoring something for productivity gain, or whether you are monitoring something for your own health or well-being. And then there is commercial applications, which is like looking at retail, building, logistics. The people talk about the global supply chain today, right? I'm sure a lot of people shop on Amazon or Flipkart or whatever your choice of online platform is, and you are able to precisely tell at where it is in the stage of the delivery, right? Whether it has been put together, whether it has been shipped, where it is in shipping, when you will receive it, to the precise amount that the person, you will exactly know the time when the person is coming and giving it at your doorstep. It's incredible. And then you have the industrial automation, and I touch upon a little bit as a focus in today's talk about the industrial automation. And then it is just not the industry, but public sector is also automating heavily. So whether it be smart cities, should emergency be connected to the police, be connected to the hospital, be connected to the ambulances. We went through a very rough patch during COVID where people died in the vans itself, ambulances itself, right? Because they just couldn't find a bed. Whereas if we are all connected to the way it is designed, then you should be able to exactly pinpoint where the availability is, who has the oxygen, all this stuff, right? So you have to really look at what do we make out of this connectivity? What do we make out of this technology? How is it really enabling humanity, right? So if all this technology is there, and we are still shopping around, moving from hospital to hospital, that's not the right implementation, or we have not really addressed the full potential of the technology, and it's getting there, right? These are all not easy to do, several systems in the equation, but we see progress. And then we have the different business approaches. You can have a lot of application domains and devices, but if you cannot monetize it, if you cannot build a business around it, then what's the point, right? People have to make a business. So people provide a lot of intelligent services. We call it the Uberization. Today, you don't wait for a taxi or an auto, or pay the bills, utility bills, whatever the utility is. Everything is online. It is kind of quite incredible how these things have come together. And I just wanted to touch upon migrate from IoT to I wanted to touch upon in today's talk more focused. I will take probably a better part of the next 10 to 12 minutes talking about industrial automation and smart manufacturing. We all know about consumer IoT. We use wearables, we use phones, we use mobile devices, but I just wanted to give a flavor for industrial IoT because it has a slightly different flavor. It is in many ways it is using the same technologies, but how it is used, what are the aspects around it are quite different, right? So even though if you look at the bar chart on the right, the consumer internet and the internet usage, the industrial internet usage is about 3 times more than the consumer internet, even though the number of consumers will be probably twice as much compared to the industrial, right? So it's quite incredible, and they say this is a pretty old report. It's not a recent report. They say that it will touch 3.5 trillion. I think we are way beyond that, and 43% of the global economy, right? So. And if you look at the pervasiveness, and we have been talking about it for the last 10, 15 minutes, we surpassed the number of people on the planet way back, like in 2006 or something. We are 15, 20 years beyond that at this point. So you can imagine that we talked about 8 billion in use. That was pretty clear 2020. So that's a good prediction. This slide was put together about 10, 15 years back. So not a bad prediction at all. So and they are saying that the number of intermittently connected devices will be greater than 200 billion at this point of time. So this is not always connected, right? So permanently connected 30 billion, intermittently connected 200 billion. People wondering about the amount of data that we generate and backhaul. Um, there was a pilot that was run. I'm not sure who did that, but it was, for people. Probably many people don't follow this, neither do I. But I read about it. There is a football called NFL, American football. In 2018, they provided free Wi-Fi, right? 5 years back, 4 years back, for all the people in the stadium, so that they can tweet, put videos, social media, whatever they want to do, right? Videos, stuff like that. And over the 5 hours, when people start coming in and the last person left the auditorium, it was like between 4 to 5 hours. The game itself is 3 hours. They cleared 24 terabytes of data. That's significant, 4 hours, right? And today, IEEE 802.11 Wi-Fi, they cover about 70 to 80% of the backhaul traffic. So I hope people understand what backhaul means. Uh, uh, why is this so much amount of data, and why do we care? Because it's coming from everywhere. You take an application, whether it's an insurance company or regulators, hospitals, doctors, city authorities, transport companies. In many cities that I travel around, you precisely know when the bus is coming to the bus stop. It's everything is connected to that level of detail, right? Soon you will also know that people are counting. There are technologies that are being developed where sensors are being developed to count people in an enclosed space. So perhaps to adjust the air conditioning. If there are so many people, it will warm it up. It's too many people, it will cool it down, and perhaps it will tell you the number of people in a bus as it comes and picks you up. Right, so it's incredible. And before I go to market demands, one thing that I wanted to touch upon when we talk about these technologies is the fact that we, apart from driving, and I thought I had a slide on that, but unfortunately I don't. Apart from driving technologies for higher speed, higher data throughput, lower latency, all these technical, what do you call, requirements, one of the key focus that IEEE Standards Association does, and part of my practice, so the foundational technology practice, is to how to build trust in systems. Today we are online constantly. We share a lot of information about our daily lives. We give away our information to a lot of authorities, a lot of agencies, either in the name of KYC or whatever be the reason that we share our information. And when we do all that, we want to see how these data is shared. What is the data governance? Do I trust the people? Do I trust the technology? Do I trust the entire system? Right? When I'm sharing these things, and it's a long way to go. So we have a particular focus on what we call as the TIPS framework: trust, identity, privacy, protection, safety, and security. So it's basically building trust on systems. I think it's very important to understand that we do those um, as we develop technologies. It's very critical part of our mission and our focus, right? So now when we go back to technology per se, and we talk about market demands and new technology driving 802.11, I told about the use case in Super Bowl. So there's a constant demand for throughput. You reflect upon your own lives, how you used to use technology and how are you are using technology today, and it has significantly grown, right? So there is a more demand for throughput, always new features coming in. Soon there is a lot of capabilities of AR, VR, metaverse, XR on your phone, Second Life, digital avatars, incredible. But these are driven by technical capabilities, and also as we do those things, we need to also make sure that the regulations is in lockstep. Today, we have on the unlicensed band, we have 2.4 and 5 gigahertz, and there are some discussions whether if we should do 6 gigahertz, right? So And I talked about this: industrial automation, process automation, healthcare and hospitals, home and building automation. Today you can control the lights through Alexa. There are smart bulbs, smart everything, right? So pretty incredible. Mm. So, and then I thought, as I said, touching upon smart manufacturing, what we did within IEEE was we dissected. Smart manufacturing is a very big area. It's a key area of focus for us. We dissected it into three big buckets: the basic generality, the techniques that you use for making smart manufacturing real, and then the different industrial applications. Whether it is tracking transportation equipment or the next generation of information technology, the energy vehicle, all these different aspects, right? So on the basic generalities, it's happening on computer vision. Today everything is vision driven. And then control systems, we see quite a lot of industrial robots, heavy usage of robots, both in the industry shop floor but also in our own personal lives. People say that in Japan, for the elderly care, there are robots that are being deployed. I had a interesting personal experience, and this is again 2019. We are 4 years behind that. uh, Sometimes when you go to hotels, you forget things, a toothpaste or a toothbrush or something like that. I was in Shanghai. I forgot my toothbrush and paste when I left India, and then I asked for it from the hotel. And then when I opened the door, there was a robot which came and delivered that. Right, so incredible. Then I followed that robot. I actually have a video. If I'm live, I will probably share that video. I followed that. It communicates to the elevator. It goes down. It goes into the lobby and gets itself plugged into the wall and gets charged. And there are about 6 robots waiting to serve different people in the hotel for different needs. You know, so I'm thinking that now if I go back to these same places, it will have changed dramatically. It will have increased significantly. And what are the drivers for the smart manufacturing? You have the services, the industrial services, which are pretty key, and intelligent factories. People might often talk about intelligent factories. A lot of factories are heavily into automation, and but the point is, when you have a lot of these systems, you need to do asset management and intelligent equipment. You need to track your assets, and everything is built on the backbone of the industrial internet. And then, of course, the software and the applications and the big data are sitting on top of it. Without going into the details, there are several standards that we are looking at. One of the key standards is what we call as time-sensitive networks. I don't want to go too deep into this, but I spoke about 802.11 and its impact. There are various standards we are doing on sensors. And oh yeah, I did have a slide, and we talked about the trust framework. So I will skip that. One key challenge we all notice, and if you read a newspaper or if you read what do you call news, we see that things are getting hacked all the time. I do not know how much people are aware, and it happened interestingly when I was in Australia a couple 10 days back, or a week back rather, and there was this whole big issue of Optus data leak, right? So people's driver's licenses, passport details, everything got leaked out. It's about 70% of the population got affected, which is like if you take 25 million as our Australia's population, so about 15 million people got affected, and that privacy was exposed. Pretty challenging, right? So that is why it's important to understand how, so the trust has not now gone down. And there is something very interesting happening. Is secure, right? And you have, let's say, 10 million people's private data, and it's very secure. What happens is, due to various requirements and applications, people share their own data to a third party. I want to share, let's say, a driver's license, which is sitting in the secure database, but somebody is asking for verification. Can you share my, I have to share my driver's license. So what is happening is, all these people are in a distributed fashion sharing that information, which is supposed to be secure. And there are applications now running to figure out what and all data has been shared by individuals and re-aggregating that entire data center, right? That was originally thought of as being very secure. So these are all becoming extremely challenging problems. So we have about 5 or 6 new programs that are looking at a top-down approach. So in the bottom of the list, I have put some protocols which is looking at specific activities of how to increase security in specific environments. Uh, but also how should we rethink cybersecurity when we talk about building new systems. So there's a lot of significant amount of thought process. It's not an easy problem to solve, but we need to start somewhere, right? And for people who are interested in the area of data privacy and building trust, we do have information on our website. You can visit standards.ieee.org. And this talks about various things, whether it's an authentication service or biometric privacy. Today, whether you are leaving or entering a country, whether you are entering your own buildings, we do biometrics. How does your school management protect your data of the student? That's a pretty significant debate happening around that. I don't think that's a great job being done, right? Data is being leaked, monetized, whatever it be. School. I get a call from people, third-party agencies about my child and what tuition she should do or he should do. It's crazy, and there is no way they would have got the data unless somebody has shared the data, right? And data is very valuable. You can monetize data, so data governance is becoming very, very important. And then you have the aspect of child privacy and ethics in autonomous systems, where softwares are making decisions. What is the ethical impact? Cliche example: when you have an autonomous car, does it protect the people on the car? Does it protect the people on the road or on the curb? What are the considerations? And with COVID, unfortunately, more and more children went online. So children privacy is becoming a very core issue, and there's significant work happening within IEEE. So I put a mapping previously on the different elements, and these are the standards what we are doing in each of these elements. And this is a quick glimpse of various standards that we are doing, which is falls under the. And I don't think this covers everything that we are doing within IEEE. It's not easy, and I've got a link to the foundational practice page, and I can share this slide deck with Anshika Dikshit, and she can probably circulate it to people who registered or attended this particular session. But we have 1451 that is on sensors. We have the 2030.5 smart energy profile. The work, actually, she did a pretty interesting work with when she joined IEEE India as a 6-month intern. This Shreya from PES, I think she was in the electrical engineering department, and she said that let me develop a distributed load management system using 2030.5 protocol. I believe that it was also adjudged as one of the good papers within that particular conference. Brilliant work. Privacy and the biometric privacy. What do I want to touch upon here? A lot of work happening on the cloud. 2302 cloud interoperability. Today I'm sure PES uses certain cloud, maybe Microsoft, right, Azure. But today, if you want to go from Microsoft Azure to Google, it is not easy. It takes a lot of effort. It takes a lot of effort, a lot of cost. So there is a lot of work happening, which is in the broad space of Internet of Things, right? So and it's coming together when we look at really a smart cities environment. And there was a QR code there, which I'm hoping, I haven't tested it in a long time, to take you to this page where when we talk about the smart cities, what are the various aspects of the smart cities, and at the core of it is the whole connectivity and the Internet of Things, right? So whether you talk about e-governance, smart grid, healthcare, transportation, so pretty complex world out there. I'm going the wrong direction. So I think this is my last 1 or 2 slides. One thing that we do is we look at what we call as centers of competence. Systems are getting complex. We within IEEE are thinking how to address these complex problems, and we have aligned ourselves over the past 3 years in the area of practices, and this is consistent with a lot of industry. So we have a healthcare and life science. These are all global practices. They work with the industry, government agencies, regulators, researchers around the world in their area of practice. So healthcare and life sciences practice is led by Maria. Mobility is led by Dr. Grant from Europe. Energy is and telecom is led from the US. I lead the foundational technology one, and then we have the new frontiers, which is looking at emerging areas such as sustainability, gaming, metaverse, things like that. The whole purpose of all this is we want to promote innovation, but when we do that, we want to do it in a meaningful way. We want to protect the public safety, health, and well-being of the people.